Hi, good day everyone. So today we'll be doing number 9, May, June 2022. So let's read the question, right? H, J, K, and L, and M, right? Are all points in the circumference. So you're watching H, J, K, L, M, H, J, K, L, right? All points on the circumference. 0 is your circle, MK is the diameter on the circle, and it is parallel to HJ. Where is HJ? Right, so this line here and this line here is parallel, right? MJ is equals to JL, and angle JMK is equals to 38. Alright, so first let's do some of the rules that we have viewed here. Alright, let's deal with the first thing they said was a diameter. Actually no, let's deal with the cyclic CYCLIC quad. Alright, the cyclic quad, which is MHGL. Alright, so the cyclic quad MHGL, opposite angles are equal, i.e., let's talk about which angles are equal. HML, sorry, not are equal, that is wrong, are supplementary. What that means is when you add the opposite angles, it's supposed to be equal to 180. So angle angle HML, that is this angle here, plus angle HJL is equals to 180. Right? Then we have angle MHJ plus angle MLJ is also equals to 180. Right, so we know, right, this is how I want it. These are the angles that would, if you add them, it's supposed to be equal to 180. Alright, now let's deal with the diameter. If the diameter, the side, the angle in a triangle, TRI, opposite the diameter is 90 degrees. Right? We know that in a triangle, we're talking about mainly triangle MK. Let's move this aside because I'm not seeing G. Right, so we're talking about triangle MKG. Alright, one of the sides is our diameter. In the angle in the triangle, the angle MJK in a triangle MKJ. In the triangle MJK, the opposite is opposite the diameter, hence that angle is angle MJK, that is this angle here, is 90 degrees. Alright, our next thing is triangle MJK L is an isosceles, isosceles triangle. So MJ is equals to JL, hence the base angles JML and angle JLM are equal. Alright, so these are some of the things from our circle that we know. So we may use this for some of the questions that are to come. Alright, so first let's just denote that this here, this angle here, is a 90 degrees angle, okay, because it's opposite diameter MK. Okay, let's go on to the first question. Explain, right, giving reason. So you need to give your reason why these angles are what they are. Why HJM is 38. So let's see what's HJM. So we're talking about this angle here. So basically they're asking you for this angle here. So none of these reasons that we have done would tell you why. However, if you look at, you think about the different types of angles and all those things, you would see that if we were to trace this along, you are seeing a Z. Now we don't call it, it's just to identify. We see that Z, we actually call it alternate angle. So once you see that shape Z, our internal angles that is found in the Z are equal. So that would be why HJZ, the one I colored with yellow, is equals to 38. Right? So what you would put in this is that angle HJM and KMJ are alternate angles, hence they are equal. Alright, let's make this bigger so we can fit. Hence they are equal, and we would say that KMJ, which they give you, is equal to 38. Therefore, HJM is also equals to 38, and that would be your answer. Alright, if you want to make sure, they did tell you in the question, it's not right, KMJ, we're talking about this angle here, and they did say they call it JMK, right? JMK, it's the same thing. Alright, KMJ, JMK. Alright, we're looking at the letter in the middle, so it's the angle at M, right, is equals to 38. Alright, this one, you want to know why MJK is equals to 90. MJK, and we already told you why MJK is 90. MJK is a triangle. Angle MJK in triangle MKJ is opposite the diameter, hence the angle MJK is 90. Alright, so we have the reasoning for this already. It's just copy and paste. Alright, let's read the next one. Determine the value of each of the following angles. Show detail working where appropriate. They want to know what is angle MLJ. Alright, Okay, so just to make my life easier, I put the images here. Right, obviously in exam room you'll just have to flip back. Right, they said determine the value of each of the following angles, show detailed working where appropriate. They want MLG, so MLG. Okay, okay, one other rule I realized I forgot this. One other rule is MG is a chord, right? And there are two triangles being produced on that chord, right? So we know that MJ is a chord and there are two triangles, TRI, being produced from the chord. Hence, the angles at the circumference are equal. Alright, so the two angles at the circumference, that is MLG and angle MK. Right, now again, forgot this rule, but it's just to explain this right here. We want MJL, so we have nothing else in MJL. However, we can find out MKG very easily because we know we have two angles and we can find the last angle. So we know that triangle MKJ is equals to 180 and triangle MKG is equal to 90 plus 38 plus angle MKG. Right, so 180 is equal to 90 plus 38 plus MKG. Right, that's 180 is equal to 90 plus 38 is 128 plus MKJ, sorry. So therefore angle MKJ is equal to 180 minus 128. So MKJ is equal to 52. Alright, now this reasoning that I put here, alright, just copy it. Now they did say determine show detail working where appropriate, so you do need to just state this very quickly that the triangle here, let's see if I can make this small and longer. Right, you do need to say because they're on the same chord they're equal, so therefore angle MLJ would be equal to 52, and that is how you get your answer for this question here. Let's look at this question. I have a circle here so you could just watch it. Angle L K, hold on, L J, that is this angle right here. Okay, so for this one you have to look at their two triangles and it's actually the difference. So to find this little angle here, M, let's write it down. Angle LJK is equal to the difference. I won't write it, I'll just write down what it is. It would be angle MJK minus minus this angle, which is LJM. LJM, right? That is this angle right here. I could denote it so you guys could see. I'll just put it in blue. This angle right here. Alright, so it is a difference between those two, the right angle and this angle here. Now you have to ask yourself, how exactly am I finding that blue angle? So we are going to look at the isosceles triangle. Yeah, let's put angle here. Alright, now we said in the beginning of this that the angle, right, we said, oh, undo that, we said this part. Right, so we said that MJL, that's the triangle MJL, is an isosceles triangle. Hence, this angle here and this angle here are equal. We already found out JLM, alright, from above. So JLM is equal to, what was it? 52. Alright, so therefore, if JLM is equals to 52, then it's L Alright, then JML would also be equals to 52. Alright, we know that a triangle is how many degrees? A triangle is 180. So 180 is equal to 52 plus 52, alright, minus, plus the angle that we're trying to find out, which is angle LJM. Alright, so we know that 180 is equal to 104 plus LMG, right? So LMG is equals to 180 minus 104. So LMG, no, it's not LMG, is LJM. I don't know why I put in, it's LJM, right, would be equal to 76. Alright, let's make this smaller so I can have space to write my other stuff. Now remember this first part here, we found out LJM, right? We know that angle MJK is 90. So we would use this formula now. Right, to put in the values. So we know that angle LJK would be equal to 90 minus 76. So angle LJK is equal to 14, and that is how you would get this answer here. Alright, now they want JHM. JHM. So we do not have this angle, we do have this angle, but we cannot assume that these two sides are equal. However, we know that JHM is actually opposite this angle. So remember, we said in the beginning that cyclic opposites are supplementary. Alright, so we are going to use this that we have here. Right, let's see. Do we have, let me enter. Right. Do we have JHM, J or MHJ, MHD? We do. So we won't use this. Delete this. We know that angle MHG plus angle MLJ is equals to 180. Do we know what is angle MLJ? Yes, we found that out in the beginning there. Alright. We said that MLJ was 52. Alright, so we'll just put in these values. This is angle MHJ plus 52 is equals to 180. So we know that angle MHJ would be equals to 180 minus 52. So that is angle MHJ or JHM. Please note that is it is angle H we're looking at between lines between J and M. So saying MHJ slash JHM is the same thing, okay? So if you see me say it a little bit different, just know that it's the same thing. We're still looking at angle H, right? That is equals to 128. So we know that this angle will be 128. So once you know your rules, you should be good. All right, let's do part B now. From a port L, all right, there's this L. R is 250 kilometers at a bearing of 0.65. So let's just write that out. So it's from L to R. That's from here to here is 0.65. Alright. Then taking ship T is 180 kilometers from L. So, right, that's from here to here at a bearing of 148. So they're saying from L to ship T, or T is 148. So we are going to put, I'm just going to put this in yellow. So from here to here is 148. Alright? So these are the things that they're telling you. This information is illustrated in a diagram below. Alright? So what is the first thing that I said? Complete the diagram above by inserting the values of angle, R, L, T. So they want let's change this color to, what's it, red? They basically want this angle here. Now we can clearly see that that red angle, or RLT, is the difference between 148 and 65. Alright, so to do this question, you simply say it's 148 minus 65 is equals to 83. So that red angle, or RTL, is equals to 83. That is how you would do this first part. Let's do the second part. Calculate RT, that is the distance between the two ships. Now we have two angles and then standard angle, which is red, and they want to find a next side. Immediately what you will think is, okay, I need to use either sine rule or cosine rule. This is not are 90 degrees. So that is the rules that you have to use. You go through the different so you ask yourself what is given in this triangle, right? We have two sides and an intended angle. If they asked you, if they had let's just say the angle, right, and then they had the angle that is opposite that the side that is opposite that angle, right, you could use sine rule. However, they gave you the two sides and an angle, the intended angle, so therefore we use cosine rule. Right, so cosine rule right, we know when you're using cosine rule, the side that is opposite the angle that they gave you, or the angle that we have to find out, right, would be what is the first term, that is r t squared is equal to the other side, that's lt squared plus lr squared minus 2lt r, not lr, sorry. So it'll be 2 lt lr cos r lt. Please note, as I was saying, the angle that is opposite the side that is opposite this angle here is this first term here, what it is equal to. So that is how I know RT is the first thing to go. So we know we want to find RT. So RT squared, we're just going to put in the values as 250 squared plus 180 squared minus 2 by 250 by 180 cos 83. Right, when you put all of this in your calculator, you'll get a value, right? RT squared is equals to 83,931.75909. Please do not approximate just yet, because you will get the answer you'll get will be a little bit off. Alright, we don't want that. We want the answer to be as close as possible to the actual answer. So you find the square root of this entire thing, 83,931.75909. So RT is equals to 289.7 kilometers to 1 decimal place. This is where you'll approximate when you get your final answer. And that is how you'll do this question. That is the distance, okay? Now they said determine the bearing of T from R. So we're starting from R and going to T. So immediately when you know your starting point is R, in bearing, we always draw that north line. Alright, let me just fix this stuff right. So we're starting from R. They want the bearing of R from, sorry, the bearing of T from R. So we're going from R to T. Hold on. Right. We want R, let's put this in a different color. I'll put it green. Yeah. Let's put it green. So we want bearing of R. Okay, R. Sorry, the bearing of T from R. Alright, we want this angle here, or the green one. Alright, now to do that, there are a few things that we have to find out. First off, we know that we can't just find r just so. What we would have to do is find this angle here. So undo this. I'll put it in black. We'll have to find this angle here. And also, let's use purple, this angle here. Right, it's easy to find those two angles, and then the green angle, the black angle, and the purple angle is all 360. So once you find your black angle, which is simple enough, and your purple angle, which is also simple enough, right, you just subtract it from 360 to get that green angle. Right, so just to avoid the situation of going back and forth, up and down, I am just putting that right here. Right, so we can see it. So that black angle here, we know. So there are two ways to do this, right? You can use the cosine rule, or you can use the sine rule. Why can't we use the sine rule? Because we have an angle and the side that is opposite it. Alright, that is 289.7. So let me just write that down. I'll put it in red. 289.7. We have that, right? And we have its corresponding angle, which is 83. Right? And then we have a side, and we want to find the corresponding angle. So we can simply say sine, we'll use sine rule. You can use cosine rule if you want, okay? You'll get supposed to get the same answer. So cosine rule is sine LRT, that's the black angle, LRT, over the corresponding side, which is 180. I want the formula. Let's not put the thing, right? Over LT, that's the corresponding side, is equal to sine TLR over its corresponding side, RT. Okay, now let's just put in the value. Sine LRT that we don't know, so that's sine LRT, that is what we're trying to find out, over 180 is equal to sine 83 over 289.7. Alright, so if we carry across, divide by 180, it'll turn to multiply. So we know that sine LRT is equals to 180 multiplied by sine 83 over 289.7, close bracket. Alright, and if you want, I'll just do this. Instead of finding out this value, you can say we're carrying across sine. There's nothing like divide by sine, there's sine inverse. So LRT would be the sine inverse of what we have here. I'm just putting a square bracket. That's 180 open bracket sine 83 over 289.7 close bracket, and then you close the square bracket. Alright, so LRT, or the black angle, is equal, so I'm just going to put it approximated 38.1 degrees to 1 decimal place. Alright, now our purple angle kind of ran out of space because I was writing big. Alright, our purple angle, we can see that 65 and the purple angle are co-interior angles, right, or interior angles. Hence, when you add 65 and that purple angle is supposed to give you 180 degrees. So again, angle NRL. How did I get NRL? This is not RL, right? NRL and angle 65 co-interior, hence 65 plus NRL is equals to 180. Right, let's just so angle NRL would be equals to 180 minus 65. So NRL is equals to 115. Alright, so our purple angle is 115 and our black angle is 38.1. So we know that, let's just put this properly, angle LRT plus angle NRL plus the bearing of T from R is equal to 360. It's a complete turn, right? We saw that. So we are just going to put it 115 plus 38.1 plus, let's just, I'm going to copy and paste this so I won't have to be writing it over. Plus this is equals to 360. So this would be equals to 360 minus 115 plus 38.1. That is the bearing is equal to 360 minus 153.1. So this would be equal to 206.9 to 1 decimal place, and that is how you would find out the angle of bearing T from R. Alright, let's go on to the next question. Sorry, that is the end of May-June 2022 number 9.